So here's another example. Sketch the trace of the plane in each of the coordinate planes. Then sketch the graph of the plane 2x plus 3y plus z equals 6. Not an easy one. So I can use my software to do it, and we'll do that below, but let me show you what you would have to do by hand first, okay? We got 2x plus 3y plus z equals 6. Well, in the xy plane, z equals 0. So we would have 2x plus 3y equals 6. So that is the same as saying in the xy plane, let me see, 2x plus 3y equals 6. That says 3y equals negative 2x plus 6. That's y equals negative 2/3 x plus 6. So in the xy plane, the y-intercept is 6, and the slope is negative 2/3. So in the xy plane, the y-intercept, let me see if I can do that here. Maybe I need to do a fat point. I'd like to do a fat point somehow. Can I get a fat point shape out of this? I don't see a fat point. Maybe I'll do a tiny circle. So here's way out here at 6, and the slope is negative 2/3. Boy, didn't do much of a circle there, did it? Oh, sorry. I'll try that again. There. That slope is negative 2/3, so I guess if I were to draw the line would be something like this, right? And it goes further than that, but that's in the xy plane. Now, let me go back and say, all right, what does it look like in the yz plane? Well, that's where x was 0, and so z equals negative 3y plus 6. So there's a intersection at 6 in the xy plane. So here we go again with the shapes. Try to get a little circle here where z equals 6. Well, that's maybe bigger than I wanted, but now I'll draw a line. Of course, it will go through this point here also. So that's got to be part of it. And now in the xz plane, y would be 0, so z equals negative 2x plus 6. Again, the 6, that's nice that we got that point there where it is. It's exactly what we wanted it to be. There, I'll make it fat. So actually, once we've got that point, I don't know what else we need to do, really, because we just take a shape and draw this line. So there it is, done by hand. There's the 3 intersection points. Ooh. There's the 3 intersection points with the coordinate planes, but I can do that with my software. If I solve the equation that I'm given here, this one, for z, and then call z a function of x and y, so f of x, y equals z, and then I can graph the function f. And as you see, this pretty much looks just like the picture I had drawn by hand. No, it doesn't. Why doesn't it look like the one I've drawn by hand there? Actually, it does, but I think I said something wrong. I was saying that in the xy plane, I forgot to divide by 3, so the y-intercept is actually 2, not 6. So this shouldn't be back at 6, it should be up to 2. But anyway, I made a mistake. But you get the idea. I did do a pretty reasonable sketch by hand, and now just to show you how easy it is to cheat on this, you can say, well, good gracious, now all I have to do is say, there's 1, there's 2, right? And that was 3 on this plane, so there's 1, 2, 3, and here's 1, 2, 3, 4. Oh, sorry. That didn't work out very well. Let me see how many I can undo there. 1, 2, what's the matter with this? 1, 2, 3, 4, 5, 5. Now I got 3. That's all I got there. Now what's going on here? There must be some kind of goofy way that this draws lines that I'm not used to. Okay, forget it. 6 hash marks on the z-axis. Ah! Alright, so anyway, there it is. Picture's pretty nice there. I think it's easy to see that those traces are indeed what I said they were. See, the 6 up here on the z-axis. Here's the x-axis intersecting at 3, and the y-axis intersecting at 2.